As we develop a better understanding of covalent bonding, we will see that for some molecules and ions, there is no single Lewis structure that can be drawn to represent or fully describe the molecule that we are trying to draw. This brings us to our next tool we have to draw molecules, which is called a resonance structure. So what is a resonance structure in organic chemistry? A resonant form is another way to draw a Lewis dot structure for a given compound. Equivalent Lewis structures are called resonant forms. They are used when there is more than one way to place double bonds or lone pairs on an atom. Let's take a look at the carbonate ion, which is CO3, the -2 charge. So drawing the structure, we get something that looks like this. We put the -2 charge out here. Let's evaluate this molecule and see what we got. So in the top oxygen, we have 3 sets of lone pair of electrons, which would give us 6 valence electrons, and we have a bond pair, which would give us 8 valence electrons. So this would satisfy the octet rule. Put a check right there. So looking at the lower right oxygen, we have a bond pair, and we have 3 sets of lone pair of electrons, so we have 8 valence electrons on this atom, and this satisfies the octet rule, so we can put a check there. Looking at the carbon, we have 2 single bonds, 2 different single bonds, and we have a double bond. Each bond has 2 valence electrons, so that would bring us up to 8 valence electrons, and that would satisfy the octet rule. So carbon can get a check. Looking at the lower left oxygen, we have an oxygen with a double bond and 2 lone pair of electrons. So that gives us 8 valence electrons, and this satisfies the octet rule, so we can put a check on that. So this molecule is good and sound. It satisfies the octet rule. But if we take a closer look at it, we can see that we can put this double bond that's on the lower left oxygen on any of the oxygens, and it would check out just fine. So then the question becomes, how would we make a structure that would represent that, where we could show that there's a double bond on each one of the oxygens? We could also have a structure that looked like this, and we could just as easy do the same thing with right here. This is where resonance structure comes in. We write each of the possible structures. So we have a double bond here, we have a double bond here, and we have a double bond here. And in between each structure, we write a double-headed arrow. And what this is saying is these 3 structures are a hybrid representation of what the true molecule would look like. So what's that mean? That means that it has characteristics of this structure, it has characteristics of this structure, and it has characteristics of this structure. So it means there's a little bit of a double bond character on each oxygen.